Hi, we've been taking up questions on circle. Under the same, I write the next question. It reads as, in a circle of radius 5 centimeter, AB and AC are two chords such that AB is equal to AC, that means the chords are equal, is equal to 6 centimeter. O equal to 6 centimeter. Find the length of the chord BC. Let's draw a figure to understand it better. Oh, sorry. This is our circle. This is the center O. There are two chords AB and AC. I name them. They don't look similar alike. I need to draw one which would look similar. Wait a minute, I now try to draw these two, AB and AC. We have to find the length of this chord, which is BC. Also, we know that the radius is 5 centimeter. This one is 5 centimeter. I can write the rest of the information here. This is also 6. This one is 6 centimeter as well, and this is given to be 5 centimeter. We have to find BC. What do we derive? As because AB and AC are two equal chords of the circle, the center of the circle lies on the bisector of angle BAC. Remember, this is a theorem. So the center of the circle, which I forgot to name, this is O, that will lie on the bisector of angle BAC. So let me just bisect it. This point of intersection, let's name as M. So OA now becomes bisector of angle BAC. Since the internal bisector of an angle divides the opposite sides in the ratio of the side containing the angle, therefore M divides BC in the ratio 1:1, right? So M becomes the midpoint of BC. You can simply write down whatever I had narrated. OM is perpendicular to BC as well, right? So that way, triangle ABM, this one, becomes a right triangle, and we can apply AB square is equal to AM square plus BM square. So AB is 6 square 36, AM we don't know, BM also we are not aware, but we need to find BM because only then we can, that will contribute towards finding BC. So let's keep BM square is equal to 36 minus AM square. On the other hand, let us take up triangle AMC. Here we will get AC square equals AM square plus MC square. This is again 36. We are not aware of what is AM square will remain and MC square will remain. So MC square is equal to 36 minus AM square. Why will be even getting this? Even without doing so, you can directly write it as BM, because BM is equal to MC. Therefore, we can write the same without even substituting these values. Anything else which might help us? Look at this small triangle that might help me. In triangle OBM, what do we get? OB square we are getting as OM square plus BM square. What was OB was 5, so it's 25. OM square can be written as OM can be substituted as OA minus AM whole square plus BM square. From here also we are getting one equation for BM square. So BM square is equal to 25 minus the whole of OA minus AM whole square. I just continue it here. So BM square is equal to 25 minus what is OA given? OA is the radius, so that is 5 minus, let AM be as it is, and then whole square. Now if you look at this equation, which I will just highlight, maybe this and these two, they are both equations informing BM square, so we can equate 36 minus AM square with 25 minus 5 minus AM square. We simply now need to find out AM square from AM from this. So let's open the bracket. 25 will come to this side, that makes 36 minus 25 as 11, and I'll carry this AM square to the other side. So if I take, it will be 20, not 25 anymore, so it becomes AM square I'm sorry, and now I need to open this one. It is 25 minus 10 AM plus AM square, and I remove the bracket, so it becomes minus 25 plus 10 AM minus AM square, thereby cancelling these two, and 11 plus 25 becomes 36 is equal to 10 AM. So AM is 36 upon 10, so it is 3.6 centimeter. AM is 3.6 centimeter. We need to find BM to find BC. So you can take any of the triangles AMB and let's substitute it with 3.6. So BM square, look at this equation, BM square is equal to 36 minus AM square AM whole square. So AM whole square 3.6 would give us 12.96. So BM will be actually a root over of this, and if I subtract, I'm getting 23.04, so it is 4.8 centimeter. If BM is 4.8 centimeter, BC here, which is supposed to be calculated, BC is twice of BM, so it is 2 into 4.8, that's I think is 9.6 centimeter. Hope you got it. Let's move on with another question here. I write down the question first. AB and CD are two parallel chords of a circle whose diameter is AC. We have to prove that AB is equal to CD. Oh, there is some error here. This should be E. Let's draw the circle first. There are two parallel chords, so I draw one here, the other one here. The circle has become a little flatter one. This I name as AB and this being CD. Oh, it says AC is the diameter, so I can just simply change this to and write CD here. This is the diameter, so I can mark this point as O, which is the center. We now have to prove AB equal to CD. Here what are given to us? AB is parallel to CD, AC is O, and AC is the diameter. What do we have to prove? We have to prove that the chords are equal. To do so, we will have to drop a perpendicular from O to the side AB as well as to the side CD, and if I do so, my perpendicular would look like this. I name the point of intersection here as LM. These are the perpendiculars which we have dropped, so you can write here under construction that AL is perpendicular to AB. Similarly, not AL, this is OL, sorry, OL perpendicular to AB. Similarly, OM perpendicular to CD. As because AB is parallel to CD, OL is perpendicular to AB and OM perpendicular to CD, therefore LOM becomes a straight line. And if you look at it, AC works as a transversal. Therefore, angle OAL and angle OCM, they become equal as because they are alternate angles. So I write angle OAL is equal to angle OCM. They are alternate angles. Now if we can prove the congruency of these two triangles like OLA and OMC, we can prove that CM will be equal to AL. So AB and CD will be twice of them. So let's take up triangle ALO and triangle CMO. How can we prove the congruency? We have already shown how AO AL is equal to OCM. Then we can also say angle AOL is equal to angle COM because they are vertically opposite. OA and OC will also be equal, they being the radii. So by AAS criterion, we can prove the congruency of the triangles ALO with triangles CMO. Once we prove the congruency by CPCT, we can write by CPCT AL is equal to CM. Now AB and CD are, because perpendicular from the center of the circle bisects the chord, therefore AB is twice of AL. Twice of AL becomes AB and twice of CM's becomes CD. Here you can write in the bracket perpendicular from the center of a circle bisects the chord. I hope you get it right. Thank you.